Good morning everybody, myself Anomalous, and today I am here to explain you an important topic in science one, that is anomalous behavior of water. Anomalous behavior is an unusual behavior of water between 0 to 4 degrees Celsius. So before that, we need to know the reason why on heating any liquid it expands and why on cooling it contracts. Simple reason for understanding, let's take a liquid. If we have taken a liquid at a room temperature, it contains some molecules, and if the molecules are closer to each other, that means density is high. Okay, and if they are far from each other, that means density is less. Density is nothing but mass upon volume. You can see the density's formula. Density is nothing but mass upon volume. It has inverse type of relation. That means if density increases, volume will decrease, and if volume increases, density will decrease. Now we'll come to our point. Our liquid is at a room temperature. Now we will produce heat. That molecules will absorb the heat energy and the kinetic energy, the velocity will increase. As they will increase their velocity, they will start moving in a fast motion and they will move far away from each other. As they move far away from each other, that means density decreases and the volume, that means the water, the liquid, it starts expanding. So what happens though? As the density decreases, volume increases. You have seen the relation? Now similarly, if we cool that liquid, what happens? The molecules, they will lose their kinetic energy. They will lose their kinetic energy and thus they will come closer to each other. As they come closer to each other, that means density increases and thus the liquid will contract and volume will decrease. This was the reason of why when on heating it expands and why on cooling it contracts. But water, it has a special kind of behavior. It shows a special behavior from 0 to 4 degrees Celsius. But after 4 degrees Celsius, it shows usual behavior like others. Now what kind of behavior? Let's see. Well, if we heat that water from 0 to 4 degrees Celsius, it should expand, but instead of expanding, it contracts. Similarly, if we cool that from 4 degrees to 0 degrees Celsius, it should contract, but instead of contracting, it expands. Now we study that in graph, using a graph. We have taken a beaker and we are heating that. The thing contains water and there is a thermometer placed over here, which shows the temperature. Now, here is a graph where the x-axis contains the temperature and y-axis contains the volume in milliliters. Now, as we produce heat to that water, the temperature will increase. Now this temperature is at 0 degrees Celsius and volume is nearly to 1000 by 50. Now, as we produce heat, the temperature will increase and as it goes to 1 degree Celsius, we will see the difference in volume. Volume will decrease and it will come to 1000 to 10. Then similarly at 2 degree, it will again volume will decrease. At 3 degree, again the volume will decrease. And at 4 degree, it has the maximum maximum density and less volume. That is, it will be contract. The water, the liquid will be water will be contract. So at 4 degree, we have seen that it has maximum density. But after the 4 degrees Celsius, as usual, it shows behavior like others. As on heating, instead of it expands, it's not water. So you have seen the behavior from 0 to 4 degrees Celsius of water. Now what is the main reason of this thing? Let's see. At 4 degree, it has maximum density. So when we cool that water from 4 degree to 0 degrees Celsius, what happens? These water molecules, they will lose their kinetic energy and they will form and they will come closer and form some hexagonal structure of hydrogen bonding. You have studied about hydrogen bonding. When one hydrogen of water molecules bonds with oxygen of other water molecules and they forms a weak bond between them. This weak bond means they have a force of attraction between them. So as they have a force of attraction, that means at 0 degrees Celsius, we can see that water, it contains hexagonal structure. They have arranged themselves in a hexagonal structure. So if they are arranged in a hexagonal structure, that means what density? It has kind of space between them. That means molecules are far away from each other, thus density is less.